Okay, welcome back everybody. Today we are going to do the Project 6.1 control SK6812. And so what is this? This is this RGB LED board. It's the atmosphere lamp, so it's got 4 LEDs that change different colors. And this is basically talking about setting mood lighting. Um, Component knowledge from the schematic diagram. The four RGB LEDs are connected in series. You see that right here. You have this output from here comes in here to this D in, to the D out, to the D in, to the D out, to the D in, to the D out. So they're all connected in series. And each RGB LED is an independent pixel, so it has red, green, and blue inside each one of these. 256 levels of brightness display and complete the full true color display of 16,777,216 colors. What's more, the pixel point contains a data latch, signal shaping amplifier drive circuit, and a signal shaping circuit, which effectively ensures the color of the pixel point light. It ensures that the color is highly consistent. So we connect this to, this is our module SK6812. 6812 goes on pin 26. And then here's our code. Our code is really long, right? So we'll kind of scrub through some of that real quick, but I'm not going to go through the whole thing because it's quite long. But so we include this library. We have this if def avr include avr power.h, and then we end this. We have a couple of define our LED pin 26 LED count for this Adafruit NeoPixel object, and then we define an object. We instantiate an object of the Adafruit. We call it strip. That's the name of it. That's our object. And these are the overloads for strip. These are the parameters that we need to define it. So let's see here. What's that say? It looks like neo kilohertz. Looks like it's saying 800 kilohertz GRB LED pin LED count. So that's what we need there. We have our setup function. We have an if statement. If define this and I think that's if this and both this are true, and then we run this method clock prescale set, and it says these lines are specifically to support the Adafruit Trinket 5 volt 16 megahertz. And as you're probably aware, it's an instance method, that's an instance method, that's an instance method, and they're all called on the strip object. Void loop function, and we have what's a color wipe? A color wipe is a function. And then these are the overloads. We need the color of the strip object. So color and our RGB values. And what's that? I think that's our brightness, if I'm not mistaken. Either that or a wait time. Yeah. Okay, so the first three are our color objects, and the second one's, I believe, a wait time. So then we have this color method called on the strip object, and those two together are the overload for color wipe function. Same thing here. We have the color method called on the strip object as part of the theater chase. It's the overload for the theater chase function. This is our theater chase function down here. So we're actually up here, we're calling this function up here, right? So that's where it's coming from. Once again, this color wipe, we're defining our color wipe function right here. So that's what this is. So now inside of our color wipe, every time we call that in the loop, we're calling this function, we're calling that function, we're calling the rainbow function. There's our rainbow function, and we have a theater chase rainbow function. So we write all four of those functions here. There's our theater chase, there's our rainbow, there's our theater chase rainbow, theater chase, color wipe. Those are our four functions. And you see those, we're calling those up here. Theater chase rainbow, theater chase, color wipe. And then this is where those functions are defined, and this is where they're called inside the loop function. So we got a for loop and basically like any other for loop we've seen. It's a little bit different. Usually we're used to seeing a number here, but this is saying if I is less than the value of the number of pixels called on the strip function, then increment I++. And then we call the set pixel color instance method on the strip object. We call the show method on the strip object, and then we call the delay function. And then very much the same down here. We have a for loop inside a for loop inside a for loop. We call the clear method on the strip object. Another for loop. We call the set pixel color on the strip object. Show instance method on the strip object, and then we have a delay function. Very similar down here. We have a rainbow function overloaded with an integer called weight, and a for loop inside a for loop. We declare a variable called pixel hue. We assign it the value of first pixel hue plus the value of I from the for loop times 65,000, etc. L. This is a long integer. It's used for huge numbers like 65,000. That's why you see an L at the end of it. It's telling you it's a long. It's telling the computer it's a long. Divided by the calculation of the number of pixels called against the strip object. And then once again down here, same thing. We have, and it's usually easier to start from the right and go to the left. We have this pixel hue value that's overloaded into the color HSV static method against the strip object. Now whatever that calculates out to is going to be the overload for the gamma 32 static method against the strip object. We have this I here is our instance method, and that's our variable value from the for loop up here. So when we set the pixel color, we need the values of this this integer up here, and also whatever this gamma 32 method called against the stripped object overloaded with our pixel hue color HSV method on the strip object. Right? Makes sense? Of course not. Our show instance method, our show method called against the stripped object, and another weight. And then our last point, theater chase rainbow, which requires an integer of weight. That's our value. Integer first pixel hue equals 0, defined as a 0. And then we have another for loop inside of a for loop with an A and a B. This one counts up to 30. This one counts in from 0 to 2. So 1, 2, 3, 1, 2, 3. Indexing at 0, 1, 2, or 0, 1, 2, 0, 1, 2. We call the clear method against the strip that sets all the pixels in the RAM to off. Then we have another for loop integer C equals the value of B. And if C is less than the calculation of the number of pixels called against the strip method, or called against the strip object, then increment C by 3. And C counts up from B to the end of the strip in increments of 3. So if B had the value of 2, C would count up to 5, and then 8, and then 11, right? So we have the integer called hue, and we're assigning that first pixel hue plus the value of C times 65,000 long divided by the number of pixels called against the strip, this method called against the strip object. We have this UI We see that. Where do we see that? We see that up here, don't we? We see that here, don't we? So do we see that up here at the top? Okay, so we're down here at the bottom. This is an alias UINT30TT. Okay, and we have this. It's basically, it's kind of like an object, and we're instantiating an object basically of this type color, or an alias. We're naming it color, but that's what it's one of these, but we're calling it color. We're assigning it the value of the gamma 32 method called against the strip object, and that gamma 32 method is overloaded with the HSV color value, overloaded with the value of hue, right up here, integer hue, called against the strip object. That calculates to this, calculates to that, the assigned value to this. And we have the set pixel color method, which is the value of C and the color here, this color, called against the strip method, or strip object. We have the show method called against the strip object, and then we wait, and then first pixel hue plus or minus 65,000 divided by 90, which is one cycle of color wheel over 90 frames. And what we get when we boil all this down, we're going to run it right now. And by the way, what we're looking at is these 4 lights on the side, and it's really hard to see because they're so bright, but everything's basically just going to kind of shine and look white, but you can see the glowing on the outside of it. Since the LEDs are actually too bright for the camera, you can actually tell the color of the glowing. So even though you don't necessarily see the LEDs doing what they're supposed to be doing, you can see the result of it with the colored shadow. So you know that it's working. But yeah, these things are super bright, and there's just, you see they're working. So anyway, that is our that's our RGB. And then, of course, to test it, the atmosphere lamps of the smart home will display a variety of colors and effects, and that's what we're seeing right now. In the next video, we are going to learn how to connect these 2 buttons to switch the color of the atmosphere lamp. So that's coming up next. Thank you for watching.